idea, something that we want to develop. So I don't know. It's interesting to see how they work or stuff like that. All right. And Sam, I can share that with you anytime if that's particularly interesting to you, because, and very bluntly, if you want, if it's helpful for you, because I know those are your clientele in a way, right? And you like getting the insights from what people think, and I will not hold back my opinions, and for good or bad. On this call, I will a little bit. Anyway, so let's get started. Kirk, if you don't mind, you could introduce yourself, tell us what you're going to share, and share.
Yeah. Let's see. Kirk Marple, I've been a software developer my whole career. Was at Microsoft in the early days. Had a company in the video transcoding space, and for about 10 years, and then have been working in this unstructured data pipeline space, especially around knowledge graphs, for the past few years. So, just going to show off. Just a quick slide of kind of level setting of what we do, and then actually I'd made a demo of kind of ingesting the TWIML podcast and then doing some podcast chapters with LLMs. So gonna show that.
Yeah. Do you have tell us about the company?
Yeah.
Mm-hmm.
Let me just share over here. Okay, so the company's named Graphlit. So what we do is basically all of the end-to-end. So if you're familiar with LangChain and Pinecone as sort of frameworks and vector databases, we're providing a managed service. And so a lot of what we do is the unstructured data pipeline side of pulling in everything from Jira tickets to Slack messages to emails to MP3s. I had a lot of experience in the media management space for broadcasters that kind of led me down this road of, really being agnostic to the type of data. And that's where we really got started. We were building a data cataloging tool for unstructured data originally. And then we had already been using NLP, already been using computer vision. And then with LLMs, we realized we're kind of a perfect long-term memory because we already had search, we already had the data ingest pipelines, and we were already built on a knowledge graph. And so really what we've done is it's for developers, so it's API first. It's really something you can easily self-service. We have a free tier to get started with. And it's model agnostic. So you can do RAG across anything from OpenAI to Mistral to Anthropic. We handle all the chunking and the text extraction and all that for you. And it's also multimodal. And so that's one of the things where, we're doing audio transcription by default, but we can also do like GPT-4 vision on images for image descriptions, OCR type things. We support Azure Document Intelligence for really their OCR for documents. And we have web scraping, we have all the kind of different data ingest and things like that. And if you want more information, it's just Graphlit, graphlit.com, and then there's a documentation site. I can share this deck later. But we have sample apps that we've just been building. One of them actually is just for podcast summarization, podcast chapters. And I could show that one here. So I just ran it while we were waiting. So it's a really simple Streamlit demo, but I can even show you the code. You can pick a podcast or you can put in your RSS feed. It ingests the podcast, transcribes it. So it's taking the MP3 from the latest episode, transcribing it, and then we have some built-in prompting to generate chapters. And so this is just an example of we can do things like generate social media posts, generate summaries, or you can put in your own custom prompt that we pass through. So we're kind of handling all of the context that goes into the LLM automatically by the transcription and the text. And then here we're actually using the Haiku model from Claude, which is really quick. I've been liking it lately. So you can see it only took like 8 seconds for processing this whole podcast chapter. And it's free to try. We have these here. You can just sign up and get a key and play around. And I'll just quickly, if we have time, just show you some of the code. It's all GraphQL. And so we have this idea of feeds. So you can create a feed to any data source, RSS, Azure Blob Storage. We just added Jira, Linear, and GitHub issues to bring those in. We now support email. So it's a feed is kind of a recurring data ingest pattern. And then we can do, we have semantic search, so you can query contents. So you can think of it almost like a CMS. It's like content management with LLMs built in. You can pull out all the metadata that we found in the podcast. And then what we have is a way that you can set up like a model preset. So we have you can set up what we call a specification that says, hey, use IQ, here's the temperature, probability, all that. And these are reusable. So you could say, you just attach this to your conversation or your summarization request and say, use this model with this detail. And that can have like a system prompt. And then, yeah, this is just a little pattern for picking the podcast URL. We create the feed, we ingest it, and then we kind of render out the chapters from that. And so we have a bunch of these now. I've been kind of getting more into Streamlit lately. You can do it from YouTube, you can do it from Reddit. Just did one for PDF, JSON extraction with tool calling. Have another one I'm working on right now for multimodal. So you put in a PowerPoint file, it rips the images, creates descriptions off of those images. Then you can do semantic search off of both the image description and the text in the PowerPoint. And then the last thing I'll say is GraphRAG is really where we're actually doing entity extraction into full knowledge graphs that you can enable for a workflow. And the GraphRAG concept that Microsoft came out with that paper is actually kind of really similar to what we're already doing, of providing that context to the LLM. And so we're going to be doing a lot more. Really, we're going to be at Microsoft Build, if anybody's going to be there in May, demoing this and talking a lot more about GraphRAG and that whole area as we build on top of the platform. Cool. Yeah. Let's keep it quick.
Okay, so GraphRAG. Suji, did you read that paper? Do you remember that paper?
Was that for me?
No, Suji. I thought he.
I have read a GraphRAG paper, yes.
Okay, from my, yeah.
Yeah, they're the one from Microsoft, yes. But that's
Yeah.
not very full of details. You have to fill in a lot of blanks yourself.
Yeah, it was pretty vague. There wasn't
So
even.
tell me the basic, if you don't mind, what you remember from that, the basic ideas behind that paper. Mhm.
So, should I go or do you?
Yeah, go ahead. We'll go back and forth. Go ahead, give it a shot.
Okay. All right. So essentially, the idea here is to extract entities from your content, and then try to link them based on co-occurrence. So that was what I did. My first iteration of that I did was I basically look for entities in the content in the chunks, and then I try to link them based on co-occurrence, right?
Oh, I'm sorry. By link, you mean get a relation?
Yeah, so link the different chunks based on actually not link the different, sorry, link the different entities to each other based on co-occurrence in, the frequency of co-occurrence across the different chunks, right? So if entity A and B, across the entire corpus, it was linked 1,000 times, it would have, or basically I was using a cutoff, right? So anything that is linked beyond more than 5 times in my case, I kept. Otherwise, I would drop them, right? And that was like basically to see how much sparse I can get. I needed a certain amount of sparsity before I could do it, realistically use it for any kind of inference. So anyway, so that was one part. The second part I actually got from a Llama index example on GraphRAG, and they used, they used, I think, an LLM to divine triples. So I don't have that kind of LLM horsepower, so I use Rebel. Rebel is a third-party model, which you can use to get triples out of. The only difference I did was the Rebel example in the getting started was like taking a single piece of text. So I changed it to batch mode for performance. And so I use Rebel to do my second iteration of GraphRAG. Unfortunately, at this point, I don't have anything to evaluate. So I'm basically building my evaluation pipeline to evaluate this thing to get to that point.
Let me ask you something. So go back to the first example. By linking, you're just saying these are related to each other, I'm guessing. These two entities.
Yes.
Maybe there's 3, who knows? But let's just say 2.
Mm-hmm.
And then how does that relate to RAG though? Now, so now you have what across your whole vector database, all your chunks. So you're counting links. I mean, you're counting entities in chunks, and you're finding the entities that occur a lot. right?
Right.
Right so far?
So I would so in on the front end, I would take my query, identify entities in it, right, and then look for entities that in my graph, right, and then look for maybe So I basically reified my graph. So well, in the first case I did not. I think in the first case I just said entity one, related to entity two, right. So I would take my first level, my immediate neighbors of the entities I found in my query, and I would do a search on them as well, right? So I
Okay,
get
so
more
the
recall.
linking is a recall mechanism.
Yes, yes.
And so you're trying to get, instead of using similarity, or you're probably using that too to rank them, but you're actually just finding chunks that have that entity in them. And so
Right,
the chunks are so small, probably, or not huge, so that
right,
it really means something semantically,
right.
right?
So it works when you have queries which kind of, are general, right? So chunks are very specific, are designed to be very, return very specific kind of answers, right? But when your question spans multiple chunks, you have two choices. One choice is to basically get, hope that all your RAG context that you get, right, all the results that you get incorporates information from both parts of your question, right? Whereas this one, you're kind of, creating a situation where this is easier for the those results to surface. So idea here is that you would have to have some kind of query classifier kind of thing, which would say, okay, this is a broad query versus this is a detailed query.
So
I haven't come to that yet.
yeah, last time I was on the call, I don't know exactly how it rates, but I talked about how, the fuck was it? It was different levels. So you would chunk
Yeah,
more
summarization, right?
broadly
Yeah,
and
yeah,
largely, and then you'd have smaller chunks. And
right,
so you'd have, like, it was that hierarchy. There was a
right,
paper.
right. That's
And
another. That's a Falcon paper.
yeah, there you go. And so there's very specific queries that are at that level of granularity. The
Right. It
smaller
would
chunks are
automatically pick
better.
up. Yes,
Yeah,
exactly.
but they
Yeah.
throw, so you'd have like three levels: really small chunks, medium,
Mhm,
large. But
mhm.
actually, they found out you can just then toss out the hierarchy and throw them all in the vector database,
Yes.
even though they're
Yeah. And it
redundant.
will pick up what it can, right?
Yeah,
Yes.
and that just seems to relate to what you're saying, which is this idea that
Yeah.
sort of,
This is kind of another way to get the same thing, same kind of approach. There
okay,
you're you're creating a hierarchy of chunks, um, but hierarchy of chunks, not of entities, right? Here you're creating a graph of entities, right? So it's a little different.
And
so
that's how we really look at it. Is there's a graph index that is on the content and what we call observed entities in the content, and then you have the chunk index, which is kind of on the content as well, and it's a hybrid between the two, and also it lets you then walk the graph, so you get your citations, and you can be like, oh, what are other things that are similar based on, it mentioned Microsoft, it mentioned, like, I mean, OpenAI, and you can sort of walk the graph and do that, like you said, like a histogram. What's the most common terms?
Mhm.
And so we kind of just use it to add more fidelity to the context, as well as that query path where you're picking out entities for search and filter.
Right.
I could
Yeah.
see one specialized piece of the graph, since I'm a librarian and a taxonomist by trade, built large taxonomies. I could see it's harder to build taxonomies automatically. That's one of those entrepreneur rabbit holes I fell into, is having a tool to help people build automatically taxonomies. I have it. But anyway, I couldn't. It's too much work. But I think it can work. But some hierarchy can get you a long way, because if someone asks about something, that there's like 15 or 20 children.
Mm-hmm.
And so you can then, or you can go up and be broader, but it gives you a real power to get granular, or to use all of those together. So you could just search not just by, I mean, it seems simple, but I think it would, I'm sure that's probably part of your graph to some degree. Most graphs,
Yeah, and
but hierarchy is,
we're
yeah.
using .org for the so we're mapping things to the classic kind of JSON-LD type entities and kind of structuring that way and being opinionated about it, and then yeah, it's giving us another path through the data.
Okay, so let's talk about the second one, the Llama index with the Rebel. That's triples, right? So now we're talking about, just, we've got different things. We're talking about a graph, and
Right.
what Sujit's talking about is like a baby not fully formed graph where you just have associations between entities, but entities that are at the heart of all of this, right? And now we're talking about triples, right? So maybe Sujit, you give us an example of a triple so everyone knows what we're saying. Although probably everyone does, but what would be an example of a triple? And then you could maybe try to connect the dots between the triple and RAG itself.
Well, so if you look at a chunk, right? Here, so the example or the data set I used did not have a. So in real life, in my work life, right? My content would can be immediately, I can extract entities because I have a dictionary-based entity NER, right? Here I did not. So I used Rebel. Rebel basically finds based on sentence structure, you have to feed it sentences. And based on sentence structure, it finds subject, predicate, object candidates from there. So I use that, and then you aggregate it across the entire corpus. And I use that, but in my work side, because I have NERs, I would probably filter the Rebel output to only using the entities that I have. So that's also another reason I'm kind of holding off from moving forward, because along with the evaluation bit, right? So I don't have a good evaluation platform.
How can you envisage using these triples in RAG then?
Same way. So once you have these triples, you construct a knowledge graph out of it, right? Across, based on frequency of the triple co-occurrence across the corpus. And and one other thing here is that because it found you triples, where the entity approach, where I just look at entities and then co-occur, find the co-occurrences, I don't really know what the relationships are, right? But now with the Rebel piece, right, because it actually identifies the subject, predicate, and object, I also know what the relationships are. So the idea here is that you kind of raify the graph, where you are connecting, all the subject to the predicate to the object, right? So the relation becomes its own entity, right? And then and essentially you're creating your knowledge graph, right? And then on the search side, when you find an entity or one or more entities in your query, you would basically look two neighbors out, right? Because now you have a relationship in the middle, right? And basically that's the whole plan. Everything else remains the same.
So by the way, reify means the way I'll say it is you can have metadata on a triple.
Yeah, so essentially you're flattening the relationship instead of, so if you look at a property graph kind of thing where you have, entity one relates to entity two. The relates to is just the link, right? Here I'm saying entity one, link to relates to link to entity two, right? So essentially it's like nodes with anonymous links, right? But the relationship is its own node. Right, so that's all.
To make the relationship, but the only reason you need to reify something like an RDF is because you need information about the node, particularly the relationship. So what information are you storing about?
The name of the node, the content of the node, because I'm going to use that piece, right, in my when I use Rebel, I'm looking to
You mean the type of relationship, basically?
Yes.
Okay.
Yeah.
Okay.
So
you use certain relationships and not others. So
right.
you've gone from this very blurry, two entities are like show up a lot together, so they're related to this much less blurry thing where you actually can say, I have all of these entities that seem to be related, but I only want the ones related in this way.
Exactly. Yeah.
Like I'm trying to think of your world, like a drug for an ailment, right?
Yeah. So
like
breast cancer is caused by this, right? So
yeah, caused by that. Or Paxlovid is a treatment.
Cured by, treatment for,
That's a triple.
Yeah, exactly.
Yeah. Okay. All right.
So why are the relationships represented as nodes as opposed to the links between the nodes?
Because that way we can, so we can actually construct. So so in my first case, I would basically construct queries. So let's say you have, COVID and Paxlovid, right? So if I found COVID in my question, I would find Paxlovid and respiratory distress and whatnot, right? Everything is linked around COVID. And I would throw out like a general recall, which says that, this is However, if I have in my question that, what are the treatments for COVID, right? So I have found treatments, COVID, right? Two entities that I'm interested in. And now I can use those and find the union. And because I know COVID and Paxlovid are related by the treatment clause, right? I could narrow down on the neighbors that I want to recall for, right?
Yeah. But why? But about the node specifically, Sam, it's an RDF kind of way to talk about all this. I think you're talking about RDF because in RDF you can't you can just have a triple, and like subject, predicate, object, entity, relation. Entity. Then what do you have there? I guess you have. What do you have there?
Entity one.
Yeah, but you have the net. But I mean, entity relationship. It's a
Entity.
URI. What is it? Basically he turns it into a node, which in RDF means there's more triples in there that make it a node, and then you can say stuff about it, right, Sujit?
Yes.
So he'd have to show that for it to make any sense. Reification sucks. It's complained about bitterly, and I think the graph world came up with a solution for it because those two worlds have been coming together. I can't remember that discussion. I don't know, Kirk, maybe you too. What do you think? What can you say about reification that might clarify for Sam? Do you have any thoughts on that other than to avoid it?
I mean, we're using a property graph, so it's a little bit different. I mean, I think there's, but yeah, the idea of having a separate, I like the Rebel idea, so I was reading about that. But yeah, we don't really have to do that as much, but we're using graph as an index to a document store. And that's kind of where the meat of the information, the metadata, the content. So the graph indexes into the vector store and the document store. That's, maybe you could look at it as that, as kind of pulling that knowledge back together. So we different approach.
So okay. So Suji was playing with a triple extraction, and we would put it in a graph, but it has all these relationships, and the point is precision. But also when we talked about the association of two entities, it was a recall. So I'm sure you could probably use those triples both way because you could.
Right. It's a balance though, right? I mean,
yeah.
But
either way, it's
to be honest, I don't know whether one is better than the other because I don't have evaluation results yet. All I have is like eyeballing results.
And by the way, the more complicated one is bound not to be better, just because it's always screws us up as engineers.
Probably, yeah.
I mean, that triple extraction is much more interesting. So the right, but it comes down to a classic search. It's an IR problem you're solving, and so to think about also just the whole RAG context. Okay, so especially with those prompting techniques that paper or that summary you said you posted is interesting because precision and recall now doesn't really come down to just getting the right context in front of you, in front of your LLM. It's actually how you tell the LLM to read the context if you use those techniques. And you can actually get good results from, they call it chaotic contexts, where you're bringing disparate information. That's kind of interesting. That's what I was trying to make in that comment. So you just like the area of IR has now also lives right in the prompt.
Yeah, I mean, we just look at it as, it's almost like you're building a compiler for the data that goes into the prompt. And really that structure of that context is really where the heart of all this is. And it's how do you compile that context from all the different sources, the related sources. And honestly, that's just the hardest part of the problem. And then really with re-ranking, figuring out, okay, how do you prioritize this? Different models handle kind of order of context, but we ended up actually, because Anthropic supports they really like XML for structure. We ended up moving to XML. So we actually put in an XML structure of all the source context. And then that seems to work across all the LLMs right now. So the text structure and metadata. And so you can say, hey, here's your source, here's your context, and then here's your prompt. Use that as the context for the prompt. And for RAG, that actually is working the best right now.
So you're saying let me step back. So when you say you're indexing your sources or your database of content or whatever. What do you mean by that? You mean you're creating a graph from it? Is that what you mean by an index?
So we have one sort of our data store is it's a hybrid. So there's JSON data that's like metadata. There's the vector embeddings. There's the raw text, and there's the graph, which is the relationship between I have a PDF and it mentions Microsoft, it mentions Amazon, and those are entities in the graph. So we have that index. And then when doing the semantic search for a RAG query, we'll find content nodes in the graph. But we also know what chunk it was on. So it's like, okay, page 4, chunk 7. And as we assemble those, what you get, like literally what we're pasting into the prompt, we now format in a structured way. We say like source ID key, metadata, it had a title, like we're giving metadata of where the context was. So the LLM kind of knows like, okay, these all came from a unique file or a PDF or a transcript or whatever. And so, think if you have like hundreds of Slack messages that you're trying to index into that, like you're essentially having to like pick and choose via the semantic search and the relationships and then put in the text of the Slack messages. But you have to give it some context so it knows like what goes together, time, and all those kind of things.
So when you say compile, that's what you're talking about.
Yeah, in a metaphorical way. Like
I get it. But you're not pre-compiling. You're probably doing it on the fly.
100%. That's the RAG pipeline on the fly.
So you've got these different.
When you talk about it.
So please go, Sam. Go ahead.
When you talk about an example of, you've got hundreds of Slack messages, for example.
Yeah.
Where are you implementing? Are you going to just take that all and jam as much of it as you can into the context, or are you using, where are you like prioritizing and like cutting off what you're giving to the LLM? Is it strictly given, limited up to the context length of the LLM and whatever you can get in there that's above some minimal threshold, or are you kind of being more selective about what you're putting into the context?
Yeah, no, that's really where the magic is, as you guys I'm sure have seen we do the semantic search to, say you have this big haystack of data, you're doing that vector-based semantic search or hybrid search to find the starting point. And so that gives you the raw chunks that match the semantic search. But a lot of times, what you're asking for doesn't really match the answer. And so we try some things like prompt rewriting to basically essentially rewrite a prompt into a better search query. We're also going to do some more things like inferring time ranges from the search query and auto setting metadata filtering. We haven't done that yet, but that's one of the things we want to do. But essentially, it's a search problem, like a retrieval problem first of how do I get that set of data that feels important. The RAG part of it is actually, the R in RAG is important to us. And then we have this sort of compiler, this RAG pipeline that says, okay, you got like 1,000 references to Slack messages and PDFs and whatever. Now, how do you organize that? That's kind of your question. We have sort of a ranking method that we do, and then we have a token aware kind of process that we can keep feeding until we hit a token limit. And then we get the kind of final result that's the actual prompt that you could like copy and paste into like the OpenAI playground at that point. But yeah, that's where, for us, that's the hardest part, is getting that ranking part right and the search part of how do you do even just looking at it very naively, it's just, you got to find your data that you want to talk about. And that's 80% of the problem that we've found.
We've been talking about that quite a bit in this context, how much of this is kind of search revisited.
I come naively at it. Like, I'm not a data scientist. I came from a different world, but it really is more of a search problem. To my naive view. And then the part getting into LLMs is really more of you're structuring it in a way that the LLM responds well on that side. And that's what we found. And we've had to do some different techniques to make sure that we want to be model agnostic, that they can just swap in and out Claude versus OpenAI and GPT-4, and they get a reasonable result. And we've come up with a method that's pretty swappable.
When you compile, you're not using LLMs in that process, are you? Compile with the XML?
Not currently. We are looking at some ways that we can maybe do that for, I've been playing around with using like some of the cheaper LLMs for re-ranking. Like, I mean, now they have like special re-ranking models like Cohere, but I was playing around with like using like GPT 3.5 for re-ranking, and compressing like, hey, here's 1,000 Slack messages, throw out ones that don't seem relevant to the prompt, re-rank them, give me a list of content sources, and then use that. So it sort of worked. Like, I'm still working on coming up with that approach. I think there's something there. It was kind of nice because it actually showed me which ones to throw away. That was actually the irrelevance part seemed to work pretty well. I'm still a little dubious on if truly ranking is needed, or it's more just a sorting up to the top to of what you put in your prompt. Like, I don't think the ordering of what you put in the sources seems to matter that much.
No. There's also that study that shows, it sees the top part and the bottom.
Right.
I mean, and it depends on the LLM.
Right. And that's the part there's a lot of tweaking that can be done at that level that,
Yeah.
I mean, as long as we know, hey, here's the number of sources that fit into the prompt, the token length, and we're picking the best ones for that, because some of them you might get a massive message in the middle that kind of overrides like a lot of stuff. And so that's an area where we've done things like we're looking at like using summaries versus if the message is long, maybe we just pick the summary rather than the actual message. And so that we're looking at a couple different things like that as well.
So I'm a little clear. Sorry, I'm a little clear.
Yeah, go ahead, Eric.
So you're using a semantic search and a vector database to do the initial lookup, right? And then from that, what happens, I think I understand, you're looking for relationships between the retrieval from the semantic search to construct a more complete context for the LLM.
Exactly. Say you have, say it's PDFs and it's pages of PDFs, and each page might have 5 chunks of text in it. We're using about 500 token chunks right now. And you may get chunk 4 on one page, but what you really want to do, you can expand the window of what you want to give to the LLM to be the entire page. And so I think there was a paper about, they called it like small to big information retrieval. And that we have an option for. So you can basically say, oh, okay, I want to get the context around where the hit was, where the search hit was in the chunk. And so that's one approach we do. And then with the GraphRAG, what we'll also do is if we see terms, entities mentioned in the text, we can start bringing in other chunks and other relationships of things that weren't found by the semantic search, maybe were found by other relationships. And there may be overlap. That's the thing we need to see is what other data can we bring in that maybe wasn't picked up by the initial vector search.
Okay, cool. So I get that. Have you done an evaluation against just plain RAG?
That's what we're actually working on right now. And so over the next month, over the next couple of weeks, actually, that we're doing a full evaluation to compare the two. And so we've been sort of prototyping with this of kind of comparing the two different things, and we're going to do a deeper dive in the next couple of weeks.
Yeah, I think it's really kind of cool concept, but as I'm listening, my concern would be we're adding a lot of complexity, and I would want to know what gain we get from that complexity, right?
Yeah. And I think, it obviously works for much bigger data sets. Other smaller data sets, you just dump everything in. Is probably what's going to end up happening. But I'm looking at it where, projects we're dealing with is like you're bringing in all your email, all your Slack, all your SharePoint files. So the corpus is big. And so really it's how do we filter into a reasonable set of data to answer the prompt? And we're looking at different ways to do that.
Are your customers mostly, or your target audience, mostly large enterprises and ones that have already gone down the property graph path?
For us, we're selling into folks that are building sort of Copilot-like things into their applications. And so we're just selling into SMB, and then we're actually we're going up market a bit more now once we're getting in the Azure marketplace this next month. But it's still selling to developers building these things. And so we're just trying to make RAG features easier, that we can connect up the data and you can just integrate these type of features very easily.
So when you sell into a smarty pants like Eric, he's like, why do I need more complexity in my applications, which is every engineer? How do you get over that? Or do you not encounter that anyway, just because the kind of customers, because there's
Most of the people we talk to, no, I mean, most of the people we talk to are familiar with LangChain, they're familiar with LlamaIndex. I mean, our pitch is just, look, you don't have to build it from parts. I mean, we'll manage it. We have all the managed data connectors, we have all the managed RAG. Like, you don't even have to think about LangChain or Pinecone or any of that. It's a simple API. And so that's where we've had people flip over to us where they were trying to build this from scratch and they realized I can move over to this in a day and just not worry about that piece of my infrastructure. So that's kind of our pitch.
So Sam, that's what I was talking about in our, Kirk's talking about. That's that's the LLM RAG platform. Yeah, there's a bunch of that. That's really a big deal now. So
yeah, and so much of it's just getting the data into it, and that's what we just provide all those connectors. I mean, it's kind of like Fivetran for structured data. We're doing it for unstructured data in a lot of ways.
That again, that's out of my brain right now.
Oh, just like data connectors for SQL servers and different servers and stuff like that. Yeah.
Sam,
you mentioned prompt rewriting. Did you mean that in the sense of evaluating and the prompt itself and rewriting it if it doesn't seem like it will produce good results, or an iterative process where you write the prompt, deploy the prompt, or run, do inference, and then depending on the inference results, rewrite the prompt and potentially do that multiple times until you get the results you want?
More the former. And so we're doing it on the fly. We have some options of like optimize the prompt for search. And so we'll actually call an LLM, GPT 3.5, and say, hey, here's the incoming user prompt, pull out the keywords and basically act like you want to do a Google search. And it will rewrite into a set of keywords. And that has given a lot better. That actually works really nicely. That when you then do like a hybrid search into the search index, and we're using Azure AI Search, which, it's essentially their old cognitive search product. And that gives you keyword, vector, and hybrid. And that works really nicely for getting the first pass of the data back. And you can give like top K kind of stuff and to your hybrid search. So
that's really cool, using GPT 3.5 to pre-process inexpensively, which then makes your next step super inexpensive because it's already been somewhat not optimized, but just pre-processed.
Exactly. Yeah. And that's what we're looking at. And now I'm really excited about the Haiku model, the results, and that's super cheap. So we might even move over to that for some stuff soon.
Well, remind me again what you were pre-processing with 3.5?
The incoming prompt. And so it's
the human prompt, the human fallible prompt.
Yeah.
So on the fly, right? So like
mismatch between what you want to give to the search query from what the prompt was, and that's what we're trying to solve in the middle, to basically make a better search query as the R step in RAG, essentially. Yeah.
Crazy thought, just connecting dots. Not that anyone's going to do this, but DSPY, if that kind of compile thing keeps going on, I could see optimizing your compiler, which the output is the context, the structured context for the specific LLM, right?
What's interesting is you may not even need to optimize it. It doesn't matter that much to be optimum, just that it's done at all seems to help so much.
Yeah, of course.
We've had to do a little bit of tweaking in the prompt engineering. Like Anthropic needs to have like a little extra nudge to be verbose in some ways, and at least the older models did. So and we probably built something like DSPY. It's probably similar in a way, but it's essentially that kind of compiler of the content. Like we just give it this list of content sources. It has all the raw text, all the metadata, and what gets spit out is a string, essentially, that we like paste into the LLM. And so
yeah, and I see this with that prompting stuff, Sujit, the chain of notes or the thread one. That's helping the LLM. You tell the LLM how to read the context. You can also tell the LLM to look at each item, each document or passage in the context and identify ones that are not any good.
Mm-hmm.
Ignore those. And so it's like you're telling it the prompt how to read, but what you're doing partly is by compiling the context, you're taking the you're trying to put it in a language and in a structure that makes it easier
Yeah.
for the LLM to read, but it's all about helping the LLM read it well and appropriately. So it's interesting those things can be in multiple locations like that.
Yeah, I was happy that the XML structure, which is kind of ironic that, I mean, using XML for this, but that Anthropic, I guess, is really trained on XML. Even if you look at the function calling, it's all XML based still. And originally we had just been putting it in JSON. And then when I added in Anthropic, I was like, oh crap, this isn't going to work because they're so XML heavy. But nicely, it was backward compatible. OpenAI loves XML too. And so we were able just to come up with that format, and it's pretty solid. So.
Yeah, that's
I
good.
love the idea
that
the
OpenAI
compile.
also loves XML. Okay, that's good.
Okay, so before we move on, I do have a 9:30 appointment. I'll have to drop off then. But before we move on, does anyone have any other questions or thoughts or about this
I just
area?
have one more question for Kirk. I think you said something that gave me the impression that the IR stuff was relatively new for you compared to some of the other stuff you've been working on, or some of the stuff that that you've been working on for a long time. Is that right?
Yeah, I mean, I've always kind of been in that metadata space. I mean, we did a lot with, I mean, like media libraries and metadata and things like, I mean, XMP and I mean, all those kind of things. And so, but what we had started with was the data cataloging and the search. And then, so we had kind of had that funnel of data in for the first couple of years of the company, and we were kind of just more doing visualization and search. And then about 18 months ago, we realized, wow, this plugs in really nicely as the R part in RAG. And that's really what we've been working on. And that's when we pivoted from just a tool to a platform to just sell the API that we were already building. And that's been about a year ago.
Got it. And so, if I'm curious if any resources stand out for you as you have kind of gone on this journey for getting deep into the retrieval side.
Yeah, I mean, it's interesting. I mean, just understanding, we'd already been following, I mean, the semantic search and the hybrid search part of it, and kind of looking into that retrieval side. Obviously, just that, I mean, that's a big area. And I mean, I'm less academic about it, honestly, than sort of pragmatic. A lot of it is just really kind of thinking about it as like, okay, I got a lot of data. How do I get the small amount of data out of that? And it's a little bit different than like Amazon search, where you're just giving a list of stuff. Like, you're trying to get more context for the LLM. And so we've been just, I mean, kind of taking pragmatic approaches that, I mean, I think it's just of, hey, how can we iterate on this? How can we get the right context? A lot of times I'll take what I've come up with, go over into the playground, paste it in and play with it, like play with the prompt engineering a little bit, and then kind of put it back into our quote compiler in a lot of ways. So, but I do, I mean, try and keep up, read all the, I mean, blog posts from everybody, LangChain, Llama Index, all those folks. And I think, I mean, they've set a kind of good first path of where things are heading. And we're really looking at this as, hey, it could be a service. I mean, that's kind of our whole plan. So
I would say, this is, of course, I'm getting all philosophical here, but it's no longer, IR is no longer IR. It's IM, or information manipulation, or information filtering, whatever it is. The point is, you're getting it into a language that you can speak to the LLM with.
yeah.
Whether that's the context or telling it how to read it in the prompt. Not all of the prompt is about the IRM. I'm going to call it information retrieval manipulation. I don't know what to do. Information retrieval compile. That's it. So I don't think there's IR. I mean, I know IR can be an isolated component, but I think if you think about this new IR C world, information retrieval compile, that's how to think about the problem. You know,
I think where the question was coming from my perspective, is that for a while now I've been talking about this observation that has, you know, to not a small degree, grown out of conversations here, which is like the folks that I see moving furthest and fastest down the RAG, you know, path, and to have the most success, like they've got search background, search chops. They think of it as a search problem. And that's really the key to get past. Like, it's easy to do a search my PDF demo. Like, you know, there are thousands of blog posts about that, but like, how do you actually consistently deliver strong results? And it's really having that retrieval mindset and understanding that. And so often I'm saying, make sure you get folks on your search team involved in that or who've been working on this. But if they don't have that, the next question is, well, where can I go figure all this stuff out? And I don't really have a great answer for that other than, well, this guy knows Sujit. And if you could just like suck his brain out, you could.
Well, the thing about Sujit is he's not just IR, right? He's IR plus IE, information extraction, right? Which is very close to graph. And he's lived in that world because, Elsevier science, they have large ontologies. So it's really a combination of IR and ontology together that makes Sujit the magic person that's much higher for $1 million because he's worth it, right? So
that doesn't answer my what is the alternative to hiring Sujit for $1 million?
Oh, no,
are there canonical
Sujit,
sources?
aren't there people out there? Who do you run into that has the most similar sort of ontology IR, if that's the way you'd explain yourself, kind of combination? Do you run into those people, and where? Is that more at those are the information knowledge type people? Where do you see those people at conferences or
where do you see them? But also, if you are trying to grow those skills yourself, where do you go? Like, what's the path? That's more the question that I'm asking.
So a lot of what I know is from my previous job at a startup, right? Where we had the beginnings of a graph, which we, got from UMLS, and then we started modifying ourselves, and we built search on top of it, right? So, so when I moved to Elsevier, I wasn't really looking to do the same thing, but it turned out that I kind of gravitated to that. They also have a ontology. And because of my history, I was kind of, pushed into that. I actually wanted to move into machine learning. So right now I have kind of a combination, basically because I wanted to do machine learning, so I know that stuff. And then I got pushed back into search and ontologies because I learned that stuff earlier. So I think it's kind of accidental. I don't know if, conferences, I think, I've been to some graph conferences. There's a gentleman called Dan McCreary. He used to be an Optum, now he's somewhere else. He struck me as somebody who has a very, very similar skill set, but his is more towards RDF, the more graph theory heavy, right?
Yeah, but Sam needs not heavy hitters, right? You need a more broad base of people to pull from to develop, like even within your company, right, Sam? So I would say it's I don't know if saying an ontology first IR person, which is what Sujit is, kind of what Kirk is too. A little bit of what I am, because I was also a bit of a search engineer for a startup, and I was a taxonomist, and although I was always I've worked for it gives you something to start thinking about. Library and library science, or where do the ontology come out? Linguistics? Where do people who are trained in ontology, or they just learn it on the job, and you pull from internally where people are dealing with that? You have to have a pretty large organization to find someone who's doing ontology stuff. I don't know outside of that. I can't think of what do you think, Sam? That doesn't really help that much, does it?
I think, it gives me some search terms.
Well, let's talk about those two sides of it. There's information retrieval, there's search engineer, there's there's ontologist, taxonomist, perhaps.
What I was looking for is more like, okay, if the components are information retrieval, information extraction, on the information extraction side is, these 3 books or these 4 papers or something is like, we'll get you to the 60 or 80 or whatever % of the foundational understanding of that part of it. And then there's this other part of it, and these 3 books and 4 papers, and the ontology is this book. Like, I'm trying to get the minimal set so that someone can know what they don't know.
So you know what? So you're not looking for a person. You're minimal. So you could start compiling that and bring it in this call, and we could talk about it a little bit, and maybe over time, Sujit, Kirk, whoever's on this call, I would put I call it a triplet. 3 angles to it so far, subject-wise. There's sort of the ontology, there's the IE, information extraction, and there's the search. Now I say that just from our analyzing the three of us here, but maybe from a RAG point of view, that seems kind of weird to think about who would be a skilled RAG person. So let's just talk about it real quick as a group. What are the other areas that someone would need to get up to speed in this discipline of RAG? Other than
Yeah, I think you guys started the call. I heard this, but evals. I think somebody said it before, but how you evaluate this honestly is like the hardest problem. You know, for what you were seeing, and I think you, Eric, you mentioned it with graphs too, and we were just doing a eval of text extraction, PDF extraction, but having ground truth. Like, what do you trust? And other than just eyeballing PDFs or like having to do it by hand. So that's just 2 cents.
Yeah, I think the least sexy part of this is like processing the data. Like, if you're scraping web pages, holy crap, you got to sit down and walk through HTML and figure out what to keep and what to throw away. The quality of the data, right?
Yeah, it's true. We've been testing out some of the other sort of competitors in this space for text extraction and things like that. And I mean, we have our own PDF extraction, but we also use Azure AI. And there's a wide gap right now of quality out there. So I mean, we're trying to see what the best is.
especially with PDFs, I've seen.
I mean, I was surprised. Like, I'll just say one of the vendors. I mean, there was a big gap of like missing data, and I think they're using an LLM to kind of autocorrect the data, and we were seeing like hallucinations within PDF extraction, which is really weird. And so there's some funky stuff out there that you got to be really careful of. So.
Are you aware of the Llama Index Cloud, Llama Cloud stuff? So if you tried it out, you get 10,000 free a week.
Yeah, that might have been the one I was just talking about.
Yeah.
Yeah. But and unstructured IO, I mean, they came out around, we've been around, we actually started a little bit before they did, but I mean, essentially we're not, like, we just used Azure AI for that piece as the best, I mean, what we found to be the best CR, so.
Yep.
And a lot of that might be how far you want to turn your knob of quality and how much you want to pay for it.
Yeah, it's a touch more expensive, but the quality we've noticed is definitely, I mean, above what's out.
So then, Sam, there's an awareness of data and how important data quality is. And that's not just like the old school ML data, ML ops. It's really, and in fact, it's really having people that really, or a person that will really understands. You look at the data, you sit there, you get super patient. You look at the data in detail and try to understand and fix and understand and fix. You know what I mean? That's part of it, maybe. I don't know.
Is anybody looking at OCR for RAG?
Yeah, I mean, we were just spending a lot of time this week. I mean, there's actually, we have a sample app for it, and you can even try it out with the basically creating Markdown from any kind of PDFs. And I mean, we're going to be posting a comparison document using OCR, and I mean, we've seen really good results with, I mean, as a paid service with Azure AI, but.
They go way back. Didn't they have OCR like 4 years ago when the cognitive services first came out?
Yeah, I mean, it was like Form Recognizer, it was called. The new V4 models that they just released, I mean, have been super, super high quality for us.
I can remember doing a little pet project. I think it was 4 years ago, where I would take a picture of the label of a 45 RPM record, and it would come back with all the text off that 45 RPM record beautifully with no, and that was 4 years ago. So
yeah, there's been a lot of Twitter threads this week about using multimodal models for OCR and how they're not really that great. But I think it's funny because I think people are like forgetting these people are like forgetting OCR exists, where this has kind of been a solved problem for a while.
absolutely.
And I mean, we're looking at it as a hybrid. I mean, we can run OCR, we can run pure text extraction, we can do image descriptions, and it all federates into content that then we can provide to RAG. So.
By the way, Sam, I wouldn't, not right now, but as we go on with more and more of these calls, you could maybe further develop what that use case is that you're asking this about, maybe for us, if you feel like it, and because it's kind of interesting to think about and and putting things together for you. So if you feel it'd be useful to, but anyway, we should go on maybe because I have to jump off in 20 minutes, and we had Eric. He wanted to share on tone and voice, that kind of stuff. Is it okay, everyone, if we move on, or is there anything that needs to be? Okay. So I told you, Kirk, I said that we just make a meal out of any little share.
This is great. This is
I mean,
fun.
you just showed us one slide, dude, to explain a teeny bit. That was actually very interesting. Yeah, I appreciate it. Thank you.
Yeah, I appreciate it.
Okay. So we're ready for our next share.
I'll share my notebook. It's a little bit of a change of speed here. So I think I might have mentioned last week that I had done a study on tone and voice, and the background for this is that I'm working on a healthcare chatbot. So the chatbot is imitating a healthcare professional.